Section 6.2, Writing Formulas for Ionic Compounds. Ionic compounds consist of positive and negative ions. The ions are held together by strong electrical attractions between the opposite charges called ionic bonds. The positive ions are formed by metals losing electrons, and the negative ions are formed by nonmetals gaining electrons. Even though noble gases are nonmetals, they already have stable electron configurations and do not form compounds. Properties of ionic compounds. The physical and chemical properties of an ionic compound such as NaCl are very different from those of the original elements. For example, the original elements of sodium chloride were sodium, which is a soft, shiny metal, and chlorine, which is a yellow-green poisonous gas. However, when they react to form positive and negative ions, they produce ordinary table salt. Sodium chloride, a hard, white crystalline substance that's important for our diet. In the crystal of sodium chloride, the larger Cl anion, are arranged in a three-dimensional structure in which the smaller sodium cations occupy the space between the chloride anions. In this crystal, every sodium ion is surrounded by 6 chloride ions, and every chloride ion is surrounded by 6 sodium ions. Thus, there are many strong attractions between oppositely charged ions, which accounts for the high melting points of ionic compounds. For example, sodium chloride has a melting point of 801 Celsius. At room temperature, ionic compounds are solids. Chemical formulas of ionic compounds. The chemical formulas of a compound represents the symbols and the subscripts of the lowest whole number ratio of the atoms or ions. In the formula of an ionic compound, the sum of ionic charges always is 0. Thus, the total amount of positive charge is equal to the total amount of negative charge. For example, to achieve the stable electron configuration, a sodium atom, which is a metal, loses one valence electron to form sodium cation, and one chlorine atom, which is a nonmetal, gains one electron to form a chloride ion. The formula sodium chloride indicates that the compound has a charge balance because there is one sodium ion, Na, for every chloride ion, Cl. Although the ions have charges, they are not shown in the formula, NaCl, of the compound. Subscripts in formulas. Consider a compound of magnesium and chlorine. To achieve a stable electron configuration, a magnesium atom, which is a metal, loses 2 valence electrons to form magnesium cation, Mg positive 2. 2 chlorine atoms, which are nonmetals, each gain 1 electron to form 2 chlorine anions. The 2 chlorine ions are needed to balance the positive charge of the Mg positive 2. This gives the formula MgCl2, magnesium chloride, in which the subscript 2 shows that 2 chlorine ions are needed to charge balance. Writing for ionic formulas from ionic charges. The subscripts in the formula of an ionic compound represent the number of positive and negative ions that give an overall charge of 0. Thus, we can write a formula directly from the ionic charges of the positive and negative ions. In the formula of an ionic compound, the cation from a metal is written first, followed by an anion from the nonmetal. Suppose we wish to write the formula of an ionic compound containing sodium ions and sulfide ions. To balance the ionic charge of the negative 2 sulfide ion, we show 2 positive sodium ions by using a subscript 2 in the formula. This gives the formula Na2S, which has an overall charge of 0. When there is no subscript for a symbol such as the S in Na2S, it is assumed to be 1. The group of ions that has the lowest ratio of ions as an ionic compound is called a formula unit.